Good morning, everyone, and welcome to our third day of architecting on AWS. Hope you had a good afternoon yesterday. Hope you've enjoyed a good restful afternoon. Just before we begin, as always, can you hear me and see me okay, please, and see the screen so we know that the audiovisual is working fine? I can see some thumbs ups. That is perfect. All right. That is fantastic, everyone. In that case, let's get started. And right away, let's get started with a quiz. Why don't we? Like we said, to review what we went through yesterday, but now in a bit of a quiz form to help with some of those exam style questions as well, albeit a little bit easier than they would be in the exam. So let's do this here. Okay, that is perfect. So shortly they should come up. Perfect. So everyone, you have a QR code here. If you can kindly please scan, or you can use the link that I have sent in chat over there on well, in chat, and you will be able to join this quiz. There we are. So you'll be able to join this quiz here, where we'll be asking questions. They're basically questions pretty much from the knowledge checks as well, but a little bit multiple knowledge checks to keep it more entertaining rather than on a certain topic in that respect. There we are. I can see people joining in. That is fantastic. That is perfect. So we'll give people a few minutes here to join. And whilst you join and we troubleshoot a couple of issues as well, just in case there are any, but we seem to be going on quite all right by the looks of it, so that should be okay. That is perfect. In that case, I'll just let people join in here. We'll give just a couple more minutes as well, so that should be all right. And in the meantime, of course, if we have any questions as well, do let me know whilst people join. There we are. I think about 5 more people, and I'll put a timer actually, just in case, so we don't go for too long. In case anybody doesn't actually want to join. There are 15 people. Should be 3 more. Naturally, I won't be joining as I have the answers, and that wouldn't be fair, if you will. Let's do this. Perfect. Also, whilst we wait to join and get started, just wanting to check with everyone if you've received an email from myself. Should be literally just this morning. This email right here with some extra learning links and the whiteboards of day 1. Okay, Arslan hasn't received it. Okay, that is interesting. So someone has received, a few people have received it, a few people have not. Very interesting. Let's have a look. Nicholas received it. Might be coming into your inbox shortly. Should have been about 10 minutes ago or so. Let's see. Yeah, I can see your email here, Arslan, as well. Let's see. Nick, I can see your email as well. It might just take a few more minutes, but if you don't receive it later as well, do let me know, please, and I will adjust. I will resend it. I can see it's a bit dark in my room as well. Maybe at a break time we turn on the lights also. Okay, I think that's about as many as we are. Once we still have 10 seconds, I'll quickly turn on the lights on my side. There we are. This should be a little bit better. And there we are. Okay, so everyone, let's get ready to go for the quiz. So please pay attention to the screen. There will be about 12 questions and they are timed. So in the actual exam, you won't be timed per question, but you will have an overall time for the entire exam if you do decide to take the exam. So a small simulation of that, if you will, but timing per question. So it's about 30 seconds per question. So let's get started in 3, 2, 1. With the first question, which Amazon S3 feature would be used to automatically copy new objects to a bucket in a different region? We are getting answers. 10 more seconds left. 3 more seconds. And there we are. The correct answer will be cross-region replication. So just as a reminder, everyone, so let's get that one up. So just as a reminder, everyone, here, let's get our digital canvas ready. S3 will be able to replicate to other regions through something called replication rules, and we decide whether the bucket is going to replicate in the same region or across regions. But of course, if it goes to a different region, then it's going to be cross-region replication as such. But remember, it is something we have to set in place, not something by default in that respect because of data governance, of course. So let's head over to the next question. Which S3 feature can force an action to occur after an event takes place within a bucket? So that will be, as the majority of you have answered, an event notification. And by default, that sends is directly integrated with Lambda, SNS, and SQS. However, through EventBridge, we could technically go across to any or almost anything as well. Let's head over to the next question. Which type of Elasticache installation offers sorting and ranking capabilities for datasets, or in other words, cleverer caching solution? Okay, so we have a majority here, but the correct answer is Elasticache for Redis. So DynamoDB Accelerator is a solution for DynamoDB it's not part of Elasticache, and Memcached is the one that does multi-threaded performance through parallelization. So it's overall more performant, but not as feature-rich. Next question, everyone. Which options are valid alarm states in Amazon's CloudWatch? And select 2 before you hit submit. 2 of these are the valid states. So the answers are quite spread out across the board. The 2 valid states of an alarm are in alarm and insufficient data. The third one, that is valid but not on the screen, is okay. Ready, alert, and failed quite simply aren't options, but of course it does take a bit of work with the service to remember the exact values. But the true ones are alarm, insufficient data, and okay. So those are the 3 valid states overall. Next question, everyone. A developer has 2 Linux applications in different AZs that must share a common file system. What is the best for this use case? Five more seconds. So we have a predominant direction here, and the correct answer is indeed EFS, Elastic File System. Now, S3 is not a file system, not per se. It's a flat file system, if anything. With S3, we store objects in buckets, and that's about it. What you see technically called folders in S3 is not really a folder, is really just a prefix. So when, for example, we go to there we go. Let's go here. So, for example, when we go to S3, and I look at those so-called folders, if you will, let's have a look. Demo 7, that should be all right. And let's say I create a folder. Folder 1. And within folder 1, let's say I create another folder. So let's say folder 2 here. These are not really truly folders, even though through the console they're called as such. They're just prefixes, because once you add something here in this so-called folder, let's drag and drop a CloudFormation template. There we are. Once we add one object here, the identifier for the object is the domain name of the bucket plus the appended prefixes as paths. This has an implication on performance and on permissions as well. So you can control access to S3 via specific prefixes if you want to. If you don't want to give access to the whole bucket, performance is handled across those prefixes as well. It's like partitioning a bucket, but it's ultimately not a file system. So the only valid choice here is Elastic File System, because it uses the network file system protocol, which is compatible with Linux. So that's why this is the right answer. All right, everyone. Next question here. What is the benefit of using RDS in a multi-AZ configuration? 5 more seconds. Okay, so we have a few choices here. Let's eliminate. It doesn't eliminate the need for read replicas because multi-AZ doesn't necessarily improve performance. It just adds more availability. It, I can argue this is somewhat right in the sense that technically they're both running. So this needs to be a little bit rephrased as an answer. But the idea is that we can't access both at the same time. Technically, only one database is for reads and writes. The other is just a database that the primary synchronizes with. And it is not across regions simply because that would be too great a latency. It needs to be within the same region. So the right answer here is number 2, or B, however you want it, to provide automatic failover across AZs. Across regions, we can take read replicas, but it is a greater latency. All right, everyone, next question here. An application support team has an app with unpredictable traffic patterns that runs on at least 2 instances. They want the CPU utilization to stay at above 75%. Which autoscaling strategy should they choose? And the correct answer is indeed dynamic, because we are reacting to the changes of a metric. We want the metric to stay at about 75%. So if it goes too high, we need to add instances, we need to react to it. If it goes too low, we need to remove instances, again, reacting to it. So the reactive one is dynamic. We can schedule scaling, but it won't matter what kind of utilization we have at that moment in time. And predictive, whilst very clever, it doesn't actually use live metrics. It more references historical data to anticipate patterns in that respect. So dynamic scaling is the right answer, but remember, you can mix and match as a general idea. Next question, everyone. Which service can invoke actions based on data from account resources and supported third-party management services? Or in other words, if something happens, something else happens. That service. Few more seconds. And the right answer is, of course, EventBridge. A very, very flexible service of notifications based on events on AWS or external APIs, and sending results to AWS or external APIs as well. So quite flexible. Next question, everyone. Which option is a valid target for an application load balancer? 10 more seconds. So the correct answer is indeed an Amazon EC2. So it's because the question asks, what can you send the traffic to as a target, not what can the application load balancer be mapped to, in which case it could have been a subnet in an availability zone. S3 and VPN connections, of course, we can't point to. They're completely different resources. Well done, everyone. Let's go to the next question. Which statement is true regarding Amazon DynamoDB global tables? I will address that, Jacek, once the question is over. Absolutely. 10 more seconds, everyone. Okay, so the correct answer here is the tables can be in different regions. It's because they are global tables. They are not updated manually in any way. We don't have to update that synchronization in that respect. And instances are not relevant here because DynamoDB is serverless. Yes, the first two options are the same. It seems like there's been a typo in this quiz. I'll get my colleagues to to update this as well. My apologies for that typo there. We will sort this as well. But absolutely, it's the idea that tables can go global in a multi-read, multi-write fashion. Now, we have a question in chat as well. What is the difference between CloudWatch events and the event bridge? Jacek, quite simply, event bridge used to be CloudWatch events. So it just evolved into its own independent service. That's the idea there. That is perfect. All right, everyone, let's head over to the next question. Only two more left. Which statement is true regarding an Amazon Aurora database? Ten more seconds. Okay, so it's only 6 copies. 15 replicas are possible per region, and multi-AZ deployments are still necessary because even though the data is replicated behind the scenes, the compute layer is the one that will offer the availability, and that can be one instance or more. So we would still need a multi-AZ deployment for high availability. Therefore, the right answer is this third one right here, integration with MySQL and PostgreSQL.
Sorry, hi Stefan. Could you just repeat how many copies is it across the 3 availability zones, please?
Sure, Leslie. It's 6. It's basically 2 per availability zone. It's in the slides. There's a good graphic of it. Let's have a look at it here. There we are. There we are. So this one right here. These replicas are optional here. We choose whether we want to have replicas, but the clustered volume behind the scenes is only 2 per availability zone. And imagine we didn't have these, then the primary instance is not highly available because if it fails, you don't have access to the data anymore. Does that answer, Leslie?
All good, thanks.
That is perfect. No problem at all. All right, everyone. One more question left on this quiz, which we'll get to in 3, 2, 1. Next question. Which options are use cases for CloudTrail data? So we have to remember what CloudTrail logged, what questions it answered. So a bit of a tough one here. Before we reveal the right answer, or answers, as there are two, can anyone remind me what CloudTrail does in chat or in our microphone as well? Logs API calls, absolutely. But it is going to be API calls for that kind of account usage, so resources to service endpoints. It's not for any particular service or application, so we don't log, let's say, inside of your EC2's API calls or those kind of elements, nor is it quite real time. You would have to take the logs, inspect the logs, and then take some actions on the logs, or at least put them in log streams first. And metric data, that is something that a different service does. Who generates, or what service looks for metric data, everyone, for the last option? If it's not CloudTrail, it's someone else. CloudWatch, Anthony, absolutely. That is perfect. So ultimately, the right answers are store log data as a record of account usage and capture root login failures. That is also something CloudTrail does. Oh, Leslie, still haven't received the email. Let me have a quick look. So I can see your... Oh, where did it go? Is this your email, Leslie? I've sent it to you as a private message. That is perfect. Okay. Give it some time, everyone. It might take a little bit of time. Maybe it's the attachments, but everyone in this chat is part of the email group there that I've, all of the destination that I've sent it to. It's possible that it's just taking some time, as some of you seem to have received it, some not. So it's not urgent. You don't need that email now anyway. It's more for your later research as well. So we'll check again, let's say at lunchtime. All right, everyone. Let's have a quick look here on the leaderboard. And Liam, congratulations, very well done, with most questions answered right, and as well in the shortest time span. So very well done, Liam. Congratulations on winning the quiz. As well, and congratulations to everyone, of course, on a very, very fantastic job. All right, everyone. Hopefully the quiz was a helpful way to have a quick look here at our services that we had reviewed for yesterday. We will do another later this afternoon to, again, give us that exercise in terms of questions. The exam itself won't be time-based per question. It will have a total time. Solutions Architect Associate exam. So it will have a total time itself, and you can spend as much or as little time you want out of the 130 minutes for per question. You have 65 in total, so about 5 times longer than what we've just done. But you do have to answer at kind of this cadence. Ultimately, it works out at about 2 minutes per question, doesn't it? We've spent 30 seconds, but with explanations, that takes us at about 2 minutes. So that's how we have to think about it as an exercise, if you will. One thing I should mention: if English is not your first language, you can ask for an extension of time as well. So that is another possibility. And the nice thing is you can actually take the test into the comfort of your own home. You don't have to go to a test center necessarily. But some people prefer to do that as well because maybe home internet is not the most reliable always. So it's good to have options. All right, everyone. We've talked about S3, we've talked about storage. There's just one more thing we needed to address here with storage, and that is data migration tools. How do we move data? We essentially addressed how to store data, but what about using solutions that are hybrid? My apologies, it seems like PowerPoint is being a little bit naughty again. Okay. There we are. And hopefully, there we go. Now it works as it should be. Right, so how do we move data? Well, we have a few options here. We have storage gateway, data sync, transfer family, and these are all requiring an internet-based, well, a network-based connection, whereas sometimes you just come with a hard drive to your data center, put the data on it, and then take it away. And that is what the Snow family is for. Starting off with storage gateway, this is essentially a collection of services that connect an on-premise location to AWS. And it comes in a few forms. It comes as a file gateway, depending on whether we're working with Unix-based environments or for Windows-based ones as well. So file gateway here, or FSX file gateway for Windows. Tape gateway for more archival solutions when we have tapes and tape robots on premise and we want to simulate the backup to S3 by writing to a virtual tape library, or volume gateway, which uses the on-premises volumes to create EBS snapshots on AWS. So from there, we can replicate the on-premise volumes as Elastic Block Store volumes on AWS. Ultimately, the storage gateway has an appliance, could be a physical or a virtual one, actually. And through that, we configure it as one of the storage gateway options. If it's an NFS or SMB, we're talking about the file gateway options. If it's an iSCSI one, it will be the volume gateway, and that comes in a couple of flavors too, actually, stored volume mode or cached volume mode. An iSCSI VTL, this is the tape gateway, and what it does is it simulates having a rack of tapes and a tape robot to back your data up to. But it's actually not that. It's just S3. But what we do is, on the storage gateway, we put a virtual tape library so that your on-premise server doesn't know the difference with the AWS cloud. I believe someone here mentioned they worked with tapes. Was it Duncan by any chance, I would like to say? Or Dave, I believe.
Yeah, that was me, Duncan.
That's
Back
perfect,
in the
Duncan. Sorry, say that again, please.
Back in the IBM mainframe days.
Of course. And would you agree that it was probably quite a minute and long-taking process to work with tapes as well, taking quite a bit of time to back them up as well as to restore if you had to?
Yeah, for sure.
Yeah, me as well, yeah.
And Dave as well, there we are.
Yeah.
And if it's something you can mention, would you keep the tapes in the same building?
No, they used to be. Often we've got two main data centers, or did have, and often they moved them from one to the other. However, both those data centers are only about 5 miles apart, so disaster recovery was probably not a huge thing on it those days.
Absolutely. So that is another aspect that used to happen or is happening with tapes for who still uses them, of course. You would have to back your data up on tapes and then take the tapes off site to mitigate physical disaster recovery scenarios as well. Now, of course, S3 is also offsite of your solution, but being live connected via a network, you can restore much easier. So that is the benefit here with the storage gateway, tape gateway. But it's always nice when I come across someone that has worked with tapes as well. It gives that extra input, which is always nice. So thank you for that, Dave and Duncan. That is perfect. Ultimately, even though we see different options here for storage services, technically, all of it goes to S3 first, and from there you go to EBS Backup or to FSX or to Glacier. So just as an idea of storage gateway. However, if you do want to go directly to other options, DataSync is another solution here for data migration. It's basically a similar process, but instead of storage gateway, you have the DataSync agent. And again, over a network, we transmit data. And that's perfectly fine, of course, for the person that's messaged me privately. Hope everything goes okay. And DataSync is able to transmit data directly into S3, into EFS, FSX, or S3. So it basically offers a bit more flexibility in terms of the destination storage source. Sometimes, though, you don't want or you don't have this connection, whichever connection that may be. Technically, it could be internet, VPN, or even direct connect. That's what we'll explore later. But it's a network connection. And sometimes we just want a hard drive brought to the data center to put the data on. Snowcone and Snowball Edge are basically those elements. The Snowcone is a device that you can fit in your hand. I believe the latest figure is about 8 terabytes in terms of storage, and the Snowball is significantly larger. It's about 80 terabytes, and I believe we had an update to 130 terabytes as well. But let's double check because the utilizable might be a little bit different. So let's see. TB here. We still have, let's have a look here. There we are. So even the 130 is actually 210. So we still have the 80 and 210 actually now. So quite a bit of updates there. And it's kind of the size of a luggage. So if we show a Snowball, this is what it looks like. There we are. This is probably a good comparison, if you will, in terms of size. It is actually quite heavy. It's about 20 kilograms as well. And you might be thinking, but 210 terabytes doesn't sound like a lot. Well, the idea is you don't just get one, you could get more to aggregate a larger data transfer solution. So it's a terabyte-sized petabyte migration solution. Sometimes, though, you might need a truckload of data. And the good thing is we actually offer that as well. So if you want a 100 petabytes worth of data storage, the Snowmobile is capable of doing that. It's as literal as it gets, a truckload of data. This is the whole storage solution here. It's pretty cool. It's very specific use cases, of course. Satellite imagery companies use it, like Maxar. So I will send you this use case if you're interested. Basically, in simple terms, they create at least 10 petabytes worth of data every year, and they need to move it off-site. So they hire a Snowmobile as well. Why do they need a truck? How do you mean, the person that messaged me privately? If so, what alternative are you thinking of as opposed to the truck? Essentially, so it's not meant to be a live connection of any kind. They generate the data and then they move it off site to AWS, because what this goes to is to an AWS data center, plugs in, and stores the data in S3, just like the snowball and the snow cone. Also, the snow cone has actually been used on the space station as well. So that is another pretty cool idea here. There we are. It's been used in the space industry as well to perform computations in the space station also. Because technically the snow cone has a few extra capabilities, even Wi-Fi connection as well. Let's see. You should mention in documentation, there we are, device types as well, 8 terabytes, and a newer one of 14 terabytes, and so on. So, not sure what I mean, but it's just virtual data. So why does it need a large vehicle? That's a good point for the person that's messaging me privately. Well, let's think of data transfer speed. So, and I think Anthony, yep, that's absolutely right. Exactly that, Anthony. Let's use this one. Let's try this calculator here. Let's say let's say 5 at a speed of the fastest internet-based speed. It will take 1,500 in these many hours. Let's say by days, ideally. 65 days, so 2 months for 5 petabytes at a full network speed. And if we put this at 10 gigabytes, that would take 6 days. But what if you have more? It will take a very, very large amount of time. So sometimes it's just faster to literally drive the hardware to the data center and put the data on it to transfer it, as opposed to a 10 gig pipe if the data set is large enough. Does that make sense for the person that's that's okay? So does that make sense, Joseph? Why we would use something so big? And in the case of snowball or snow cone, how will you choose that? So Arslan, it depends on how much data and how quick you need to transfer it. The snowball is the most commonly used. So let's see, do I have to find an image? The snowball is the most commonly used, and think about it this way. This fits in the back of a van, so we can bring it to your data center in 1-2 days. Maybe it takes 1 or 2 or 3 days to transfer the data on it as well. And then another 1 to 2 days, so a full week to transfer the data into AWS. If you have a regular ISP-based internet connection, so let's say we're talking about this much data, and we can only transfer it at a 1 gig speed. This would already take 10 days, but this is 10 gigabytes. We need 10 gigabits, actually. There we are. It wouldn't take 10 days, it would take 80 days. So that's already a long time. And it's assuming you can use the whole transfer speed. So you would just make this calculation, Arslan. You would have a look to see if it's worth waiting a month to transfer the data, or would it be more sensible for your use case to get 1 snowball or 3 or 10 as well? But it's not always for data transfer, really. If we won't explore this into too much depth, but they also have compute. So this is a pretty cool use case for potentially processing data at the Arctic Circle. This has actually been done to study various polar ice caps movement and those kind of elements. They've been used in Asia near flooding rivers to compute changing levels in tides. And they've actually more recently been used in the Eastern European conflict to save government data, for example. So they've been dispatched over there for the government to put their data on and then migrated to AWS. So, of course, the very unfortunate situation that's unfolding there, but to save that information. So there's more flexible use cases there as well. Does that make sense, Arslan, as a few possibilities? That is perfect. All right, everyone. So this is the idea with data migration. We have a few options here. There are quite a few things to choose from and more other than these. We can choose the network connection, something that we'll explore later on today. But now, unless, so we will ask if there are any questions, but if there aren't, we will go to automation. So everyone, do we have any questions? And if not, +1 or a thumbs up in WebEx, please. Just giving a few seconds here in case anybody is typing up. But I can see a lot of thumbs ups, so hopefully that should be okay. Okay. Everything that I have done so far, everyone, has been manual. So better to do things more automated overall. So what provisioning resources do you use so far out of the ones listed? I know Andrew mentioned Terraform. Do you use CloudFormation or Elastic Beanstalk as well, by any chance? And let me just say, other, that's not listed on the screen. CDKs, Jacek, that's very interesting. Oh, there we are, Elastic Beanstalk as well. So quite a few options here, quite a few options, pretty much all of them, really, as an alternative to CloudFormation. Of course, Jacek, if you're referring to Terraform, indeed, that does take you cloud agnostic, but unfortunately, being an AWS course, I can't really go too much into Terraform, but it does offer those capabilities, not being vendor specific, of course. Right. Ultimately, we will be referring here to AWS technologies, but on the same principle of automation, and we will focus on CloudFormation as on the way to achieve that. We will touch base on 2 other elements as well. My apologies, everyone. I think I might be coming down with something, and I will try not to sneeze or anything out loud, but I do apologize for any interruptions. So, everyone, we will be helping our CTO here achieve simplification of infrastructure building, as well as deployment, maintaining, and scalability of our applications in the cloud. And our focus will be CloudFormation, which is infrastructure as code. even in our drawing here, if I were to do this multiple times, it wouldn't be consistent. Even simply drawing this out freehand will have its downsides. As you can see, the more I rush, the more different it looks. So normally, what we could do is, as we have our resources, so let's just build a very few resources here. There we go. Instead of defining them and deploying them manually, we can write all of this into code, more specifically into infrastructure as code templates. Let's just get a few here. There we go. Load balancer, internet gateway, and let's get ourselves some Lambda functions as well, and an API and an S3 bucket. There we have it. To consistently and repeatably rebuild this template, this stack over here, we can define all of this in a CloudFormation template. We can define VPC, EC2s, subnets, of course, security groups, NACLs, RDS as well. And we can also define Lambda, API, gateway, S3, and more as well. Take this template written in JSON or YAML and pass it through CloudFormation. And CloudFormation is the infrastructure as code service that will generate this infrastructure. So in other words, CloudFormation is going to be the one issuing the API calls. It will be able to give us repeatable, reusable infrastructure by submitting that template and creating the resources based on it. It's very good for reusability. Say you develop you deploy your environment for development, and then you find out it's working well, it's gone through testing, so you will then deploy it in production as well. Then, if you need to make changes, whilst you can do them manually, you shouldn't. Not as best practice, at least. You can update the template, you make a change in the template, and that change, once deployed, it propagates through to the other solutions, through to the deployed stacks as well. The process is, write and create your template. Once it's done, you push it to CloudFormation, and CloudFormation calls the APIs to launch those resources, which result in a stack. Now, everyone. Can you launch an EC2 and then a VPC? So let's say option 1, or do we have to go VPC, then EC2? What is the correct order? Absolutely. Order number 2, we need the VPC first because the EC2 is dependent on a network. Now, CloudFormation is quite simple. Can be quite simple. You can define as little as this. For example, this will create an S3 bucket. The name of the S3 bucket won't actually be hello bucket. This is the logical ID. This is how we find it in the template. But once the bucket is produced, it's going to have a physical ID as well. Physical ID. But what if you need a bit more complexity? What if you have a whole architecture and you need some order here? Normally, CloudFormation tries to launch everything at once. It doesn't go in a specific order there. Normally, a VPC will launch quicker than an EC2, of course. But if you have some dependencies, if you have a specific order that you need, you can empower this with more capabilities. So, CloudFormation anatomy is very relevant to be studied here, because you can add quite a few other elements. You can have, besides resources, which is exactly the services that you can launch, and that's really the only required element. The others are optional. So as we'll see, optional across everything apart from resources. Even though they are optional, you can add conditions, you can add rules, you can add parameters, mappings, so you can control and handle how that template deploys very, very granularly. For example, let's see conditions here. You could say if a certain resource is ready, then you can pass to the next one. You can reference parameters. So if we have the prod parameter, then we do this. If you have the dev parameter, then we launch a smaller instance. We should have a few examples here as well. There we are. So we have conditions referencing the environment type. If it's prod, we create the resources as well. And if not, we don't. So it can be quite powerful, or it can be quite simple as well. It depends on what you're trying to achieve, but it will be repeatable, reusable as well. Now, this is a simple template that I'm drawing here, but I could add IAM, I could add more, I could add WAF as well, so security. As a best practice, we would separate different elements of logic, such as here. We could have a template that launches multiple different stacks, depending on those conditions and parameters and the very advanced use of the CloudFormation anatomy. Or we could just have multiple templates altogether, because ultimately, let's say I have a template for my front-end solution, one for my back-end, shared space network, and so on. Let's say I'm describing a dev team 1, management dev team 2. Basically, a few users, different read-only permissions, full permissions to Lambda, those kind of elements. This is the stack of, let's say, maybe we're thinking here Sainsbury's order basket processing. But then we have a different set of templates to describe an architecture for the self-checkout tills. So how we get messages and process the messages for payment and all the rest of it. This is architecture for payment and all the rest of it. The rest of the same levels of architecture. This template over here. All that we reference, we stick the same dev team and management team with the same levels of access. This is for this architecture. We just this for this architecture. One output of a template high level touched on. It's quite fascinating. So, but we normally do can do depth coverage. One or cloud lot more depth on CloudFormation. Let's use that. So let's launch a sample look at that. On AWS really well. What will to show the console is give something with. So what we'll achieve by telling CloudFormation about this, we will do it. What we'll achieve by telling CloudFormation about this template. So it will launch an EC2 instance, absolutely. Any other particular details that stand out? For example, how big is this EC2? User data is added, Jacek? Absolutely. E3 small. Very good, absolutely. So let's do this. I will add a template with new resources. There we are. We'll give it a name, demo EC2 CloudFormation. That is perfect. There are various configurations we can choose, and I will submit this. Perfect. So this is happening here, and if we go to EC2s, which is not something I have launched, it's CloudFormation launching it, you will see that an EC2 is launching now without my involvement. Well, without my direct involvement, let's put it that way. This is the one. You can see it's already running. It's initializing as well. So we have a resource. In CloudFormation, I can see I should, and I don't have any outputs here. Okay, so I haven't defined any. I can see the resources though. So logical ID, this is what it's called in my CloudFormation template, but this is the actual ID of the instance. Now, I will show you on a different template here. You can choose to have outputs. Maybe I want that IP address of the EC2 so I can view the actual website. This, of course, is not the EC2. It's from a different example, but it is an output. Out of all the things that CloudFormation produces, maybe I just want something specific to be pointed out. So I could use that in an output. Right. What if I want to change the instance type here? Do we remember the steps that we need to take to change an instance type? So if I want to have that as a T3 medium, for example, very good, Joseph, for if we want to do it through CloudFormation, but manually it would be stop, change, start. So that's 3 API calls. Stop the instance, then change the instance, change instance type, and you can see I can't actually do it because the instance is running. It's not something we can do live. And then start it again. So I would have to monitor it to do that. CloudFormation will know how to do that by itself. It's AWS based, so it will understand how to do that on AWS. If you do manual changes though, manual, there we go. CloudFormation is able to detect that as well. Ultimately, now my resource doesn't match anymore my actual template. So what I can do is detect drift or manual changes, if you will. And in the results, there we are. It's already noticed there has been a modification. And it's telling me the tag was meant to be this, but it's actually this now. Let me just open something here for the next demo. There we go. But let's actually modify the instance. So I'm going to update this template, replacing the current template, or I could edit it in place if I want to use the current one, or even in Designer, a visual tool, a pretty useful tool to work with these CloudFormation templates. It's a visual drag and drop editor of your code. There we are. It's just a simple EC2, but if I add, let's say, an API here, let's say a REST API, it's already generated the code for it, and by selecting the resource, it takes me to the relevant code for that part. And I can also EC2, let's see, so it needs volumes or subnet. Let's get a subnet in here. There we go. So if I put a subnet there, for example, and I put the EC2 inside the subnet, and I connect the two, we should see, where is the connection? Probably not here because I've already hard-coded the subnet ID. I'll drag a different instance. There we go. In this new instance here, you can see the instance and the subnet ID is referenced through this connection. So it does give you a bit of that initial starter. You don't have to code everything from the get-go. It's pretty useful at that. But you still have to, of course, add the required properties, which in an instance case would be an image ID. So it's a pretty nice tool in that respect. You can work with the code directly or use that visual editor. Let's now just also update our stack. I already have it configured. So I'm going to replace the template. Now notice this. My next template, so not this one, but the one I'm replacing it with, no longer hard codes the instance type. Rather, it references a parameter which gives me a few choices here. It gives me some possible values. So this is how we can empower CloudFormation templates a little bit more. As you can see here, I can actually choose now T2, M4, T3 small. So let's go with T2 micro. We'll go next, next. I'm even told what changes will apply. There is a change set being generated, and I could investigate this closer if I wanted to, submit it, or simply say delete the change set. But I'm happy with it. I'll submit it. And if we check the EC2 as we do that, you will notice that CloudFormation is stopping it and is going to, there we are, it's already stopped it actually. It's stopped it, it's stopping it, it will change the instance type and then start it again. So it knows to take all those API calls by itself. In a nutshell, that is CloudFormation, everyone. Like we said, it's a service that we don't normally cover in a lot of detail here. So do we have any questions before we touch base at a high level on a few other automation aspects? Or are we okay?
I have a question about CDK. What is usually, in terms of new features, what is usually delay between CDK and CloudFormation references or CloudFormation release, let's say?
Sorry, so what is the difference between CDK and CloudFormation?
No, what is usual? Because sometimes I found the AWS CDK has not features which are given by CloudFormation, and it said it's in development. So do you know what is the delay between, or what is this asynchronous between CDK and new features added into CloudFormation stuff?
So that depends on the language. So CDKs, to answer the question there for everyone as well, are cloud development kits, a way to use CloudFormation with a programming language of your choice, such as Python, Java, and a few others as well, for example. So that code is then transformed into a CloudFormation template in JSON or YAML. Let's see what languages are supported. Or let's actually have this.
I guess the most popular Python, Python and
Absolutely.
TypeScript or JavaScript.
TypeScript, absolutely, I believe is one as well. But what features will be supported, that depends on per language in that respect, because it depends how they're developed. Like you mentioned, some elements are in preview. And if I go to software development kits preview languages, I think Rust is no longer in preview, but so let's see. Rust should be already there. Let's see, preview. Preview. I have to find that again as well. But you're absolutely right, Andrew. Some are still being worked on, and we do mention that as well. Learn. Let's see. It does mention somewhere about those. I'll find that particular article, and we would definitely have to investigate. It wouldn't be a consistent. This is the difference, or this is the latency. So it's on a language and feature basis, I would say. Does that help, Andrew?
Yeah. Thank you.
No problem at all. Any other questions, everyone?
My question is very simple. Basically, if you're just starting out on CloudFormation, what's the easier to learn, JSON or YAML, or is it personal preference probably?
It is generally personal preference, but YAML tends to be more human friendly. So if we have a look at CloudFormation templates here, so let's have a look. JSON is this would be JSON, and now YAML it's easier on the eyes. Also, YAML supports commenting, so we could. There we go. We could comment out code without losing it, something that we can't do in JSON, for example.
Okay.
So this is a benefit here of YAML, but at the same time, if you want to send a CloudFormation template as a message to DynamoDB, perhaps, maybe you store this template as part of a message there, you would need it in JSON, because that's how DynamoDB understands it ultimately, as that file, for example. So it depends on what you use it for, but if you solely use CloudFormation, I would recommend YAML as a developer.
Okay, thank you.
No problem at all. And Bhavdeep mentioning SES in AWS CDK is not available. That could be, of course, in AWS CDK is not available. That could be, of course, if you've come across it not being available, that might very well absolutely.
Document or like something which can say which all services or the resources can be done using CDK.
Sorry, Bhavdeep?
Is there any like there are so many services, right? So just wanted to know like which all services can be implemented using CDK and which all cannot. So just wanted to know, is there any such AWS document or article available for that?
it should be per the CDK documentation. So if we check at the CDK level, we should see, probably not here. Let's see, let's CDK Python. There we go. This should help. Let's see. This is just workshops. So I will find that as well. We should definitely have something like that for the simple reason that we have. There we go. This is the one. Yes. So this is the one that I was thinking about.
Okay, it's similar like for Python, same should be there for TypeScript as well, I'm assuming.
It should be. And let's see. Do we actually have? I think we might actually have SCS here.
I was searching it for like identity verification automation along with the SES service. So we need to create an email and then that needs to be validated. So I didn't find anything which was available. There are on top of it some other work being done.
Would
So,
this help here, Bhavdeep?
yeah, I tried the CFN email identity.
I see.
Yeah.
Okay, there we are. So it might not be every feature, of course, in that respect. Again, language is updating at different speeds as well, but absolutely, this is where you would find the all the information. And for SDKs, similarly as well.
Yeah.
Python. Boto 3 libraries here as well. This is the one. All right, everyone. Let's have a look further at a few more possibilities. Jacek mentioning, just found out it's possible to mix CloudFormation with CDK. If you mean, Jacek, you can launch CloudFormation through CDK. Technically, as CloudFormation is a resource that can be launched through CloudFormation. It is very broad. You can even launch different organizational units with CloudFormation. It is quite huge. But that is about deploying infrastructure, everyone. What about afterwards? So I recommend we have a quick coffee break here. We have been going on for about an hour and 15 minutes. So might as well, let's have a quick coffee break. And then when we're back, we're going to have a look at these deployment tools as well. So let's put a timer on the screen. There we are, a 10-minute coffee break. And when we're back, we're going to finalize the module and go through a few other serverless and microservices solutions. See you shortly, everyone. Enjoy your break. Welcome back, everyone. Hopefully we are all back from a quick and relaxing coffee break. Right, so the next activity being a lab, after we're done with the next part of teaching, let's launch lab number 5, please. Build a serverless architecture. So lab number 5, please, for our next activity after the next teaching part. There we go, signing in, and then anytime now. There we are, lab number 5. Now, we have a few short modules left here, including finalizing this one, of course, with about 5 more minutes of discussion. But just wanted to ask for everyone if the following plan is okay with everyone, since we also have 3 labs, so it can be a little bit, how should we say, sporadic teaching, if you will. So it is 10:30 now. If we go until about 11:20 with teaching, then lab until 12 o'clock, and from 12 to 1 we do another bit of teaching session, so when we will look at networking at the edge and the cloud front, and then we go for lunch and lab until what would that take us? 2:45 roughly. So 2:45, 3 o'clock. So basically lunch and lab a little bit later today, but with a fairly large chunk of time also given to the lab in a short time frame as well. Sorry, well, soon. How does this work for everyone? Does this work all right as a plan, or would we still like lunch kind of at the regular time, in which case I will absolutely adjust in that way? We're getting thumbs ups all around. That is perfect. So that is good. If at any point you would like me to change it in any way, do let me know, please. All of this is British Standard Time, of course. So there we are. Right, teaching. Okay. So everyone, in that case, let's have a look at our final bit of discussion here by managing the infrastructure once it's been deployed. We can do that with Systems Manager and with other tools. There are other elements to talk about as well in terms of CDK, Solutions Library. There are quite a few more automation aspects, including Elastic Beanstalk. Now, you know how you need to know AWS in order to work with CloudFormation, because you need to understand what an instance type is, what an AMI, what a security group, what a Lambda function, environment runtime, and all of those aspects in order to define them here. Well, with Elastic Beanstalk, you just need your code. You upload your code to Elastic Beanstalk, and Elastic Beanstalk provisions everything for you without you having to do almost anything at all. It used to be more direct in the past, not anymore, but it's not saying it's harder, it just gives you a bit more control. So let's have a very quick view here. Okay, come on, AWS, there we go. So if I go to Elastic Beanstalk, again, we won't spend too much time on it. I just want to show you the simplicity here. There we go. Beanstalk. And I create an environment. I give it a name, demo app. Elastic Beanstalk. And then I could quite simply, after I choose the language that I want to work with my code, maybe I choose Python, maybe I use PHP, I upload my code, but in my case, I'll use a sample example, and then I could choose some configuration presets, but the idea is here that you don't have to. I go next. I can influence the Elastic Beanstalk environment, but let's say I'm new to AWS, so I'm not sure. I'll go just next, all the way to the end. I can influence VPCs, load balancers if I choose high availability configuration, volumes, and more. But like we said, that's not the focus. The focus is simplicity. So you can quite simply go next. In the past, it used to be a one push button. You could still configure all of this, but through a different way. Now it's just like this. And there we are. We have an environment being provisioned. It's really just an EC2 being launched. And once it's ready, we will basically get our code on their website. So this is what Elastic Beanstalk is meant for. And really, it is a set of predefined CloudFormation templates behind the scenes. Because what it does, it actually uses CloudFormation to launch that infrastructure. So there we go. If we go here, you can see this is the Elastic Beanstalk environment creating right now. From a management perspective, we would have to look at other solutions. We can also reference solutions library as some of the best practice already put in place CloudFormation templates by other AWS architects. So if we go to solutions library, you will find various templates and solutions. There we go. Content localization. This sounds interesting. There's a CloudFormation template for this architecture right here. So if I download it, open it, I could see exactly what is being provisioned as it's being built by the architects of this solution. I could pick and choose what I want. Maybe I like the way they've defined their instance types or other elements, maybe the CloudFormation stack definition here. So I can either take it all, pick and choose. Ultimately, the template is free to use. The software that might be used as part of the template might cost. So there is additional implementation guides as part of the solution library to be mindful of. We talked about CDKs as being able to write CloudFormation templates as part of a language that you're familiar with, such as Python and Java. So we addressed this as a question earlier. And Systems Manager is how we would manage our solution post-deployment. Systems Manager is a big service, but we really only have this slide on it. So I'm going to show you the console so you see what you can do at a high level with Systems Manager. Once you have some deployed resources, even on-premise servers, you can manage them in Fleet Manager. You can inventorize to see what kind of software you're running on them, for example. There we go. I have enabled Systems Manager on 3 of them. I'm running Linux 2023 and Linux 2 on 2 of them. These are my top 5 applications, some utilities mainly, and various other elements. I could perform automation actions, run commands as well. I could perform patching at a particular schedule, rate-based, and for certain patches that I want. So I can control quite a lot about these elements. There we are, run commands. Maybe we update Windows, apply chef recipes, or let's see, run Docker actions as well. So we could work with the containers from this side also. It is a very big service. We really only just touch base this much on it here. But if you want to learn more, as always, please let me know. Up next, something a bit newer, Code Whisperer. So Code Whisperer is a way to improve coding efficiency or speed, if you will, by giving you an AI coding companion and security scanning real time as well. The idea is you can tell Code Whisperer you can enable Code Whisperer and give it human readable commands, and that will give you the relevant code for your request. So this is what I was launching earlier. Let's see if that is ready. So we can actually see it in action. And I know we're not in the same physical room, but I can hear discussions and comparisons with other services out there as well already. That is perfectly fine. That is a normal expectation to want to compare things. Come on, console. There we go. So what do you think a benefit of AWS Code Whisperer will be over other code supporting AI tools? Purely by the fact that I've called it out as being AWS. Integrated Ryan and improved security. Absolutely. Being part of AWS, it means that, well, quite simply, it's part of AWS security suite as well. So let me just get rid of this. Zoom in. Right here, I'm in my integrated development environment where I've told Code Whisperer here previously to create a DynamoDB table called, let's say, groceries with the partition key, a string called product, and the sort key, a number called ID. Give it one RCU and one WCU. Let's challenge it a bit to see if it understands the acronyms. This could just as well be an email. And there we go. It's already giving me suggestions. It's defining DynamoDB here. It's calling the create table method. Called it groceries. So far so good. It's defining the schema, so the primary key definition here. Identify the product. That's perfect. Partition key. It started off by saying what's the partition key and what's the sort key, by the looks of it. And let's see, will it tell them to be strings and numbers? Yeah, attribute definitions. So that's what it's doing here. Oh, need to help it a bit. There we go. So all I'm doing, everyone, I'm just accepting suggestions. I'm not actually writing or copying the code from anywhere else. If it doesn't give you a suggestion, you have to prompt it. So it's a hotkey. On Windows, it's Alt-C. There's documentation on how to do it as well. But the idea is, whilst it gives you all of this, you of course have to double check the code, but ultimately it alleviates some of the burden off you to have to check documentation every time for every method. So there we go. This is the definition of the DynamoDB table in a Python script here. And this one, I could then either run here locally, or I could make this a Lambda function. So could be quite quick to develop this way as well. The good thing is it also offers those security scans. For example, if you try to provision an S3 bucket that is open to the world, it will give you those recommendations of, hey, maybe you want to close this off. So everyone, neat tool to help with that as well, of course. It is ultimately to help with your development practices, not to replace developers in any way. Of course, it's meant to reduce complexity and essentially speed up development. So everyone, like we said, we will go through the knowledge checks as well, kind of in the quiz fashion that we've done earlier, but we'll do that after lunch. In the meantime, let's switch over and talk about containers briefly. And as we are changing topics, do we have any questions?
About AWS Elastic Beanstalk, is that commercially used in production environments by companies?
It can be, Pravin, but it's not recommended. It's more used for testing your code on an AWS platform and to get started on AWS. So as you've seen with Elastic Beanstalk, I'm in a different account now, but you've noticed I could see my EC2, I could work with it. It's recommended that if you actually go down the production route, to go through CloudFormation directly, because Elastic Beanstalk is a simplification of that. Does that make sense, Pravin?
Yeah, thanks.
No problem at all. Any other questions, everyone? Or are we okay to have a look at a few other bits and pieces? A short discussion on containers and a slightly longer, but still fairly short discussion on serverless.
I have a question. Can we export the Beanstalk stuff to the CloudFormation template?
So there's nothing to export, Jacek, because it is an actual CloudFormation template. So if I were to actually go to my other environment here, so there we go. So if you see here in CloudFormation, when we launched that Elastic Beanstalk environment, it literally launched a CloudFormation template. So it's already there, basically. This is what Elastic Beanstalk gave us, this template through CloudFormation. So there we go. This is the template. It's not formatted nicely, but there we go. This is by Elastic Beanstalk through CloudFormation.
Okay. Yeah, thank you.
No problem at all. All right, everyone. I believe you already mentioned that you're using containers, but how much would you say? Generally more than 50%, with a few teams not being 100% sure, and that is perfectly fine. Well, let's have a high-level overview of containers and container services as well. Because ultimately, we want to help our compute operations manager handle independent components of our application, so service failures are more localized, as well as, of course, updates. Because what we will be exploring here is microservices delving into containers. Microservices help with decoupling, everyone. And one element of decoupling we've found initially was implementing a load balancer to avoid this tightly coupled kind of architecture. Just imagine if you added another EC2 here, you'd have to connect 1, 2, 3. And then if this fails, you would have various requests failing as well, because ultimately they would be leading to a black hole solution. So it's not ideal. That's why decoupling is recommended to handle independent parts more efficiently. Even taking one single unit, a monolith that does everything, and split it across logical different components that could be served by different elements of compute. Maybe user management in a blog forum could be handled by Lambda. Topics, so how you select what you post your blog entries to, that could be handled by EC2s, and the actual message processing solution handled by containers. This gives us the ability to maybe we want to add MFA management on our users. We don't have to take down the whole blog website. We just have to update our Lambda functions. It gives us more granularity to how we perform changes and updates, and DevOps practices really focus on microservice and serverless as well. We've already seen how an application load balancer could use path-based routing to route through to EC2s and Lambda functions, and also we could do it to containers, which is what we'll have a look at next. Because containers are a way to have your code, your application code, including any dependencies and configuration, all neatly boxed up in one single container. This container will not have an operating system, and that is quite important because it means it will be standardized and transportable to other units of compute that can read containers, such as Docker, for example, because you would need a technology to read containers. But other than that, it won't matter as much what operating system you have, in the sense that the underlying compute is just there needed to work with the container. And the purpose is decoupling and reusability. Again, let's take an order processing solution designed in a more monolithic way. We have an order logic, market logic, and reporting logic. All of these elements need to look at order history. But we are doubling up that code, that overhead, into each and every part of our application, when we could just have it as a single bit of code, as one logical unit that can be referenced by different perspectives of our application, therefore more efficiently using our resources. So rather than having 3 applications all with their logic built in, we are sharing that, and we will scale it if we need to. Similarly, in terms of how we use the hardware under the hood, containers will make better use of the actual hardware than virtual machines. Traditionally, if you own the physical server and it's quite literally next to you, if you will, we wouldn't need virtualization necessarily, so we could just use the actual physical server. And that would be an efficient use of our resources to handle our apps. But if we're working with virtual machines or EC2s, naturally, that physical server has to be split through the use of a hypervisor, meaning this physical hardware will have an operating system, and then each EC2 will have an operating system, ultimately doubling up on that workload as well, really having a lot of resource used for overhead. Whereas containers won't need that. They will share the underlying operating system of the physical hardware, and all they need is a containerization engine, such as Docker, to read containers, or to, well, work with containers. So it makes more efficient use of the resources. Now, there are different ways to work with containers, but as we generally work with quite a lot of them, we should orchestrate them in some way, because otherwise it would be a little bit tough to handle. Maybe they're just containers themselves, maybe they're containers on EC2s, containers on their own. We need to control that. So that's where we will look at the services we have on AWS with Elastic Container Service, or ECS for short, and Elastic Kubernetes Service, or EKS for short. This is for Docker-based containers, and this is for Kubernetes containers. Much like EC2s, though, containers need an image. We need to define what application is on that container, what does it look like, software-wise, and those details. That will be in the Elastic Container Registry. We'll talk about these shortly as well. So, ultimately, the idea is this. We have two services, ECS for Docker, EKS for Kubernetes, and in terms of saying where the container image comes from, that is ECR. And that's exactly what we will do. We will decouple a monolith application by essentially saying, reference the user service container image to launch user-based containers. We can version them as well. Topic image, likewise, and message image as well. And ECS will be the one to orchestrate how many containers do we get. Do I have one user container? Do I have two? Will they scale as well? So will this service capacity be able to go up and down as well? Because we can do that. We can scale per container service. In other words, if I take this here, let's take this slide. There we go. So these are our containers, aren't they? These services here, I'll take them as such. There we go. These are our containers whose images are in ECR images. And we can launch these containers in a deployment. So there we are. And I can launch more of these. I can scale just the topic service because we are really searching for various topics on our blog. And then as the messages start to be published, the users start commenting on blog posts as well. A lot of messages are coming in. Now a lot of new users are registering because we are popular. So we need to scale this part. But it's a more efficient use of resources because instead of having EC2s that do everything and we scale the entire EC2, rather we use resources more accurately. And when we just work with it this way, this is called Fargate or serverless containers. Meaning, quite simply, we don't manage any server. We could if we wanted to, though. So whilst you can deploy serverless, you can also do this. So this could be my EC2, and I could be doing this. Launch one of these containers, one of these, one of these, one of these, and then lots of message containers. But what do you see now? What should I do now? I'm launching containers on EC2s, but there might be an issue very soon. What should I do now? Okay, let's run into the issue. I'm getting more user registrations. What should I do to get more user containers? Scale Auto-scaling the EC2, absolutely. But if I deploy over EC2s, I have to control that. I have to manage that as well. So it just gives me more work, but also more control. Ultimately, that is the idea here. We can launch either across EC2s or across Fargate. But if we launch across EC2s, quite simply, I have to manage them too. Ultimately, ECS will be a fully managed orchestration service integrating with AWS, and it offers us those flexibilities to launch across EC2s or in Fargate mode as well. And Kubernetes, even though it's a different container solution, it will work from an AWS perspective the same way, meaning you can launch Kubernetes in serverless containers mode or across EC2s as well. Ultimately, everyone, it's about the level of effort that you want versus the level of abstraction. Both Kubernetes and Docker-based containers can be launched across, so both Docker and Kubernetes containers can be launched across EC2s or serverless. And like we said, we don't really go into depth here. It's really just meant as a high level, hey, these are containers kind of module. But we usually get the question, why would you even launch it across EC2s if you're meant to have it more abstracted away? The reason is very simple. You need roles on an EC2 to configure access, and technically you need roles on containers to configure access as well. Also, there will be network configurations that you can control at the EC2 level. So you can control this part also if you need to. So it gives you that level of control which you wouldn't have in Fargate. But at the same time, of course, it's more effort. And even in Fargate, though, you still have to choose the network that you're launching these containers on. So you'd still need a VPC. So everyone, any questions on containers? Short and sweet module, but any questions?
I have a question, just to remind on Fargate. So in Fargate and ECS. So you said to orchestrate them, you use a Fargate for orchestrating. So to understand, ECS is more a container. So we need a Fargate. Is it like just to make them more stable and to make sure that is it for auto scaling up and down? The Fargate just orchestrates everything together, rather than a bunch of containers that you can manage.
Let me just correct one element there, Arslan. So Fargate is not an orchestration tool; it's a deployment model. ECS is the orchestrator. So if these are Docker containers coming from Docker-based images, so let's say Docker-based image, then in ECR, we have Docker-based images. From there, we have these Docker-based containers here. We technically have something called a task definition, which define which container image we're using to launch these containers, what port mapping, what protocols as well, and those kind of elements, potential actions as well at launch time. And through this, we define some services. Services are just like the container purpose, if you will. So we have service, the user service. I'm going to say blog and message. Then the actual containers be deployed. My apologies, Arthur. Are you happy if I mute you while I explain, just because of background noise? There we are. Thank you very much. So the service, we define it to say minimum, maximum, how many containers, basically 2 and 8, for example. This is saying how many and how big the containers will be, how much compute will they have. And then we launch the actual containers, which we refer to as task images. So this is defining what the container will look like by defining the image in ECR, what the image will map to in the task definition. And the service basically says it's kind of like the auto scaling of the containers, if you will. Then the task images, the tasks is what we refer to containers. These will be deployed. So let me take this. Actually, I'll just scroll to the right. These can be deployed as Fargate or EC2s. And the difference is in the utilization of the resources and the level of control. So if I deploy over Fargate, let's do this as well, versus EC2s, the idea is this. Our resources are utilized more accurately, but with EC2s, I will have to control the EC2 usage. There we go, one EC2, another EC2. Does that make sense, Arslan? A little bit better now? Oh, and
Yeah, so it makes sense. So basically, you were saying Fargate is when it comes to the services being defined by ECS, but Fargate is the one who's going to deploy those, utilize it, so deploy those resources. So that's why I was trying to get my mind clear with how you differentiate between ECS and Fargate, understanding logically. But thank you, that clear.
No problem at all, Arslan. Exactly right. ECS is where you orchestrate, where you handle what kind of containers are launched and when. And it's Fargate where we deploy them to, basically. It's just the cloud, if you will. Naturally, there are servers behind the scenes, but since they're abstracted away, we call it serverless because we don't manage it. And EKS, exactly the same in terms of orchestration and Fargate with EC2s. It's just that it's a different container engine. Of course, there are more intricate details with Kubernetes. They will have kubelets and pods and a control plane node as well. That's why it's generally regarded as more effort than ECS. So Kubernetes as a technology tends to be a little bit harder than Docker. So everyone, thank you for your attention on this module. We technically have a networking module next, but like we said, it makes more sense to cover serverless and then the networking with edge together. My apologies, not sure why it jumped to this one. So before we go to serverless, to cover what's needed for the lab, do we have any questions? Or any further questions on containers? And if not, please let me know with a +1 or a thumbs up in WebEx. Fantastic, everyone. In that case, let's have a look at serverless technologies. Right, and it seems like, once again, this is being a little bit naughty. PowerPoint here. There we go. Okay, come on, PowerPoint. My apologies, everyone. I may have to do a few changes here shortly, because it seems like PowerPoint is playing a bit of a fun one on me, but there we are, now it's working. All right, so serverless, everyone, is a concept that means we don't handle the servers. They exist, but it just means AWS is handling it for us. So, how would you answer this question in terms of your familiarity with serverless? Some familiarity or more familiarity? That is good. Quite a lot of a little bit and a few of deep level knowledge. That is perfect. Again, this is a very high level module. Normally, we have dedicated 3-day courses just for part of this. I alone teach about 7-8 days worth of developing solutions as well. So it's a huge concept. In this module, we will talk about various serverless solutions at a high level and understand how they work and how they influence our solutions. So, let's start off by saying that our application development manager looks to optimize solutions to reduce operational overhead, wants to create messaging queues and notification services as well with push-based notifications, quite a bit of serverless and orchestration. So, so I don't keep you too long, we won't go into API Gateway first in the order of the slides. We will go into the messaging tools. So it's relevant to the next lab as well. Serverless, everyone, is the idea that you don't need to provision or manage the infrastructure itself. Remember when we provisioned a Lambda function earlier? If I go to Lambda, quite simply, all I have to do is just give it the runtime. I don't have to manage any servers. And it was very quick, very precise billing model. See, if I create a function, no infrastructure to manage, just the code. Very consumption-based pricing. DynamoDB per read or write capacity unit. Very precise as well. Lambda per millisecond as well, so very precise. And it scales by that unit of consumption. Again, here, Lambda with concurrency actually, and more. A lot of security features and built-in high availability as they are regional instead of AZ based. Many serverless technologies that are there. Lambda, we will talk about messaging tools, about Kinesis. We talked about DynamoDB and Aurora, and we'll talk about a few more as well. This is just an example here of a serverless architecture, and after the lab, after you build one as well, we'll have a look at a few examples as well, some that I have built also. API Gateway can be used as a first response to your request, a place to a single endpoint to accept multiple HTTP method calls to an API. And from there, we can put them in a place such as SQS where messages will wait for a while, and then we can consume those messages by a set of containers, based on which we can notify our customers of the order placement, and we can also record the order details in a DynamoDB table. Fully serverless solution here, and I will exemplify a few more. But like we mentioned, we're going to do API Gateway after the lab. So I'm going to go straight into messaging tools with SQS and SNS. So everyone, let's go here. There we are. SQS is a solution that decouples processing of messages between a producer and a consumer. Because sometimes an end consumer could be overloaded. Let's imagine this. Let's say we have an EC2, that is your website, application layer as part of a bigger architecture. And this EC2 produces messages. Maybe it comes from, maybe those messages are essentially orders from a front-end solution, customers that are placing the order to our website. So those orders are coming in and we are formatting those messages so we can process them later downstream. So we're producing quite a few messages here. There we go, quite a few messages. And those messages will have to be read by Lambda. And what if this Lambda function can only take these many executions? And any more, and it will get throttled. If we were to send all of these messages to Lambda at once, it might be able to process some of them, but these ones will get discarded because we've overloaded Lambda too much at once. So instead of sending the messages straight away to Lambda, we could do this. Let's get rid of these. So instead of sending them to Lambda directly, we could put them in a queue. Simple queue service. And we could essentially store them in SQS for a while, or up to 14 days with SQS specifically. So coming back to that architectural why are we storing them in, why are we decoupling this with SQS? Well, an alternative would be to increase the concurrency on Lambda, but this could also result in a very expensive solution, and maybe then the downstream service here also gets throttled. So if we want to even out the flow of traffic or of data, we could decouple it and buffer it with something like SQS. And now Lambda can take the messages and process them as well as needed. We won't go into the full technology here, but Lambda can do this quite cleverly. It can actually take batches, identify errors as well, remove, and then perform smaller and smaller batches until it notices the error message. Also, there are other implications here that can be researched in other courses, such as developing serverless solutions on AWS. Bhavdeep, just to mention here, I think that might actually be useful to you as well, based on our yesterday's discussion. So we won't address it here in depth, but just if you want to, developing serverless on AWS really looks at the performance implications on this interaction.
Okay, yeah.
Okay, so everyone, since we are talking about Sainsbury's, let's actually go to Sainsbury. And let's talk about customers. Customers that want to place orders at a till. And we have a teller here. And we have an exit sign. Of course, they will have to leave the market. Again, we are a technical cohort, but it's always good to try to remember these things in a non-technical way as well sometimes. When we queue up, much like in an SQS, to the till, we go in a very specific order. We get called forward. This is very important. The teller, the consumer of the messages, says next please, or in other words, in our architecture below, Lambda polls for messages in SQS. SQS does not send messages across. And of course, in order, we go to the tail. We go to the till. Hi, these are my products. Thank you very much. Have a nice day. Second customer as well, in a nice and orderly fashion until everybody gets processed. This is called a first in, first out queue. It is a type of SQS queue. But there is another part of this of the market of Sainsbury that functions a little bit differently to processing these customers. What would that be? So if you don't use the till, what do you use at the market to pay for your product? The self-checkout, Pravin, absolutely. So we have the self-checkout. Customers go to the self-checkout. We have some self-checkout tills here. And before they actually go and exit, number 1 goes into the queue, number 2 goes into the queue, number 3, number 4, number 5. Who's the first customer to leave the store? Someone says number 4. Quickest, any? It depends, isn't it? Because both just a banana. You know what, Jacek? Let's do that, because you're absolutely right. We need to give some details here. There we go. Come on, there we go. 16. There we are. So let's go with banana for customer 4. Let's give some other customers here. Tissues, them, sip, paracetamol. This is me, obviously, and tea, because as you can see, I'm a little bit, there we are. This is number 2. Number 1 just has some beer and some pretzels. There's a game they might want to catch as well. Number 3 has some gum, and number 5 has some water and a cake. There we are. So based on this information, what order would you give? Let's go with number, if you don't mind, Jacek, I think a gum might go first, maybe the banana, because it enters quite quickly as well. So let's go like this, number 3 and number 4. Not much as well, isn't it? So what about next? So number 3. What's the other order here? Yeah, could be number 5. Absolutely. Number 2, number 1, we have a few suggestions there. I'm going to go with number 2 and call it a day. Number 1. Is number 1 going to actually leave? Or right away? Needs age approval. Number 1 has something that we can't quite process yet. So, first off, This right here, the self-checkout, is the analogy for a standard queue. A standard queue does not guarantee order, and it is faster as well. So the drawback, not as precise. The benefit, it can be much quicker. Now, number one here, this message fails to process. So we can send it to a dead letter queue. This is not a third type of queue. This could be FIFO or could be standard. It's just another SQS queue, which we've said, right. It will act as a dead letter queue, as a secondary queue to which we send requests that can't be processed. And here, maybe we have a different processing logic. In our analogy, this might be a manager that needs to check the age, or maybe it's just an EC2 to check for errors or maybe retries and those kind of elements. So we can configure SQS like this also. And Lambda, more specifically, has a direct integration in that respect where, let's say you have a function that fails to process. We can add a destination configuration for certain invocation types where on failure, we basically send a message on SQS queue. So we can have a decoupled workflow where we perform those operations and handle the error, or at least monitor and inspect the error. So there we are, everyone. SQS, it does have a few more features as well. And it is used in a decoupling scenario between a producer tier and a consumer tier to give time to the consumer tier to process. And if there's an issue, we can offload the messages to a dead letter queue. We will talk about some of the other features after the lab, but essentially, there is a counterpart here called SNS. And a very important thing here. Let's say we have SQS and we have some producers. I'm going to call these producers EC2s. And they all produce messages. Let's say we have a green message here, a blue message here, and a purple message here. They all put their messages into the queue, like this. Consumers, on the other side, could be Lambda functions, will look into the queue to take the messages. So this Lambda function sees this message, takes it with. This Lambda function sees this message, takes it. This Lambda function sees this message and takes it. Overall, that ends up being a one-to-one messaging, everyone. As you can see, the purple message was produced by one EC2 and ended up being consumed by one Lambda function. So what if these Lambda functions also need to process this message? Perhaps this one checks the product ID, this one checks the order ID, this one reinterprets that, puts a timestamp and invoice issuing as well. Different options. Well, SQS can't do that. But SNS can fan out messages. So SNS is a solution where a publisher, different naming convention here, not publisher, not producer, publisher, produces a message, sends it to a simple notification service topic, and this fans out the message to all subscribers, or some of them. You can filter that if you want to as well. So the message ends up to all of these subscribers. However, it does not keep the messages at all. So if the subscriber can't accept the message, then it's going to be dropped, essentially. There are some retries and redrive policies, but ultimately no retention period. However, you can get the best of both worlds if you change the subscriber to SQS and you put Lambda after SQS. So what we can do here is basically this. Right, we won't send the messages straight over there, but rather to an SNS topic. So we put all the messages on SNS here, and then we subscribe to this SNS topic, multiple SQS queues that will all, because of the fan-out architecture of SNS, they will all have those messages, and now we get these Lambda functions to read from these individual queues as such, and therefore all of these Lambda functions will be able to process all of those messages. In conclusion, SNS is a one-to-many solution, which has no retention, whereas SQS can have a maximum of 14 days retention as well, and it is a one-to-one solution in terms of message polling as well. And this is poll-based, while this is push-based. So everyone, do we have any questions here before we go for lab for about 45 minutes, let's say? And
Yes.
Yes?
I've got a question. What exactly is the advantage of putting an SNS before SQS? In this case, I mean, is it giving a particular advantage in doing this?
So the idea is that if we don't, then we would not be able to process downstream all of those messages. So imagine these are all orders of products. Let's say, so on just to kind of relate it to Sainsbury's market, you will have different vendors using Sainsbury's, isn't it? I believe there's also, what is it called? The home, not rituals. Let's say home products. I know there's a vendor that does home or Deliveroo. There we are. So one of them could be Deliveroo for food, for grocery deliveries. I know there's a home products things. Habitat. Thank you, Anthony. That's the one. So Habitat as well, which is its own company also. So maybe we process messages from Habitat, or that will need to be processed for Habitat as well. Argos, there we are. That's perfect. So these messages will be processed differently, isn't it? Or with slightly different headers and all the rest of it, because we need to inform those vendors. If we put them in a queue to decouple, so the end consumer has time to process those messages, the problem is we'd not get all the messages to add timestamps on. So think of it this way, Pravin. A customer buys Habitat products. We inform the vendor, we process the message for Sainsbury to be able to send out the order. But then for our internal analytics, we want to add timestamp. We want to maybe do financial analysis. I'm thinking here, perhaps the way I do it sometimes, I pay with a card from different currencies. So maybe we, as Sainsbury, want to see how many bank transfers are happening on our products. Do we always get payments in British sterling, or do we have payments in dollars, for example? And what else here? Financial products as well, Jacek, of course. Let's see, what else could we do here? Timestamp. Invoice. Yeah, there we go. Invoice. I was thinking more along the lines of rating, maybe feedback on product, customer satisfaction, those kind of elements, as we do have a financial processing there. So quite diverse way of looking at those messages. We don't get to add a timestamp here. We don't get a feedback here because we don't process all the messages. So that's why we need to make sure all these messages get to all these consumers. So a popular way to do this, a quite popular architecture type, is to send all those messages from all those producers to SNS and to make sure we keep them long enough to process them. That's why we send them to different queues. Does that make sense, Pravin? Why we would do this? This way we can add timestamp, collect feedback, and financial analysis or invoicing on all orders from Habitat, Argos, and Deliveroo as well.
Yeah, thanks, got it.
No problem at all. And let me just say, this is one way of doing it. Also, we will talk after lab about Kinesis. It's just one slide, but Kinesis has shards which can support ordering, handling of shards, auto-scaling, and more. So to some extent, we can do this per shard. However, in that case, in your Lambda function, you need to have the Kinesis consumer library and shard management code to understand how you're using the shard as well. So there are alternative architectures here. With serverless, sometimes you get quite a bit of choice and two different architectures can achieve the same thing, almost to the same performance, where really the only difference is what you're used to or how you want to decouple. So there are various possibilities here, of course. And of course, Nikos, absolutely, SQS gives you the benefit of dead letter queues as well. But that being said, technically we can implement dead letter queues at other points as well here if we need to, for example. But that would, of course, be dead letter queues are still SQS though. So that's the beauty of serverless, everyone. It can be flexible, it can be in quite a few different ways. Any other questions, everyone, before we go for lab?
Can we do sorting messages in SNS?
Not sorting in SNS or SQS per se. So in SQS, you can just maintain order of messages published by having FIFO, first in, first out. But if you want more performance, you would use standard queues. So that's the extent of sorting that we could do essentially in that respect. You could do some sorting logic to Kinesis data streams, though. Jacek. Does that answer the question?
Yeah. Thank you.
No problem at all. And all right, everyone. If there are any further questions, do let me know, please. Otherwise, please carry on with lab number 5. And I will put a timer on the screen here for the lab. I'm going to say 14 minutes for the lab here as well. Okay, let's say 40 minutes, and we will check in where we are once we come back from it. And if we need more time, we could complete it during the lunch and lab period. If anybody has further questions, do let me know, please, as well. Otherwise, please carry on with lab number 5, where you will essentially be building a serverless workflow involving SNS and SQS exactly with that fan-out architecture. Enjoy, everyone. Any questions? I am here behind the screen.